Welcome back. If you've been following the series, you know we've been building something massive. We started by laying the foundation, manually crafting our OSPF underlay, the literal highway for our data. Then we moved to the overlay. We didn't do that the hard way. We used the Meraki dashboard and we hit the easy button and watched as hundreds of lines of complex configurations were pushed to every switch in the fabric in seconds. But here's the million-dollar question. Does it actually work? Today we're not just looking at configs. We're going to verify the fabric. We're going to look under the hood. We're going to trace the data, and we're going to prove that our tunnel is solid. Grab a coffee, because we're about to see if our fabric is alive. Returning to our Meraki dashboard and landing on leaf 4. This is a vtemp, and all of our leafs are vtemps or VXLAN tunnel endpoints. You can think of these as our customs agents. It takes our data, it wraps it in a VXLAN envelope, and sends it on its way. Let's start with performing the command show VNE VNI and look at these VNIs, which are virtual network identifiers. These are our room keys. You can see that there's a 10221 and a 10222. Those are DAGs, or what we call distributed anycast gateways. Because those VLANs or broadcast domains are stretched across multiple leafs, we wrap them in a VNI so that the fabric knows exactly where they belong. And remember, the VXLAN wrapper adds 50 bytes of overhead, which is why our MTU is set to 1550. Don't let your packets get stuck on the tarmac by not having the correct MTU. But wait, do you see VLAN 200? It's missing. Why? Aha, you caught me. It's because VLAN 200 isn't a stretched layer 2 segment. It's a routed network. We don't need a specific L2 VNI room key because we are using the L3 VNI as our elevator to move traffic between subnets. The elevator doesn't care which floor you're on, it just gets you to the right VRF. Now let's jump to the spine. If I run the NVE command, nothing happens. Why, you ask yourself? Because the spine isn't a vtemp. It doesn't know what a VXLAN tunnel is. It is the traffic cop. It never touches the actual data packet. It just makes sure that the map is updated so everyone knows where to go. Now you might be thinking, wait a minute, Paul, doesn't the data physically flow through the spine? And you're right, it does. But here's the aha moment. To the spine, your data is just an oblique encrypted black box. But the leaf has already wrapped the data in a VXLAN header. The spine can't see your MAC address, your IP subnet, or your VNI. It has no idea what's inside. The spine just sees a standard IP packet and uses the OSPF underlay, our high-speed highway, to route the packets to the next destination. It's a route reflector for the BGP control plane, meaning it manages the map of the fabric. But for the data plane, it's just a high-speed forwarder. It moves the traffic, but it never opens the envelope. It just keeps the highway clear so the VTEMs can do their job. That is the critical distinction between the control plane, BGP, and the data plane, VXLAN underlay with OSPF. Let's return back to leaf 4, and let's check the directory. I'm going to type show IP BGP L2 VPN EVPN and press enter. That's a mouthful and a big command. This is the BGP table. The type 2 routes, that's our MAC to IP address or who are you info. As I scroll through the table, you can see that there are type 2s. These are our clients, and as you can see, it is a MAC and IP address mapping so that the fabric knows exactly where the clients are. The type 3s that you see, that's our group chat for broadcast traffic. And the type 5s that you see are our GPS coordinates for the entire subnet list. This table is the brain of the fabric. If this is empty, the fabric is blind. Now, how do the switches find each other? Look at these loopbacks when I do a show IP interface brief. Loopback 100 is our vtemp source, the identity of the switch. Loop 301 is for our OSPF underlay, the highway infrastructure, and 965, that's our L3 VNI gateway address. These aren't just numbers, they are the GPS coordinates for our entire network. Without these, the switches wouldn't know how to route the encapsulated traffic to each other. And at the very top of the table, you will see that VLAN 2 is our underlay, and that was built a few videos ago when we built the underlay. Real quick, just so we can see that all the leaves have similar information, let's jump to leaf 3 and perform the show NVE VNI command as we did on leaf 4. Notice that leaf 3 has an extra VNI. It has 221, 222, 231, which is our bridge DAG, and 965, which is our routed traffic on VLAN 200. Next, look at that crazy command, show IP BGP L2 VPN EVPN, and see that all of our type 2s, our type 3s, and our type 5s are also on this leaf. And finally, let's look at the show IP interface brief and see that they has the same 3 VNI loopbacks of 100, 301, and 965. It does look like we have it on leaf 3, and of course, we have VLAN 2 at the top of the list. This is the moment of truth. I'm going to jump to a client that is connected to the floor switch 4, which is in turn connected to leaf 4. As you can see, I have a command prompt open, and I'm going to perform the command ipconfig release and ipconfig renew to get a new IP address from the DHCP server on the handoff router 1, which is north of the borders outside of the fabric. The client sends a broadcast, the leaf intercepts it, wraps it in a VXLAN, and sends it to the border. The border unwraps the VXLAN shell and sends it via layer 2 to handoff 1, which is our DHCP server. The server sees the request, sends an offer back, and the process is reversed. Let's check out the handoff 1 switch. I'm going to do the show IP DHCP bind command to see the bindings, and bam! There's the bindings. The DHCP server knows exactly who our client is. The fabric is healthy, the tunnel is clear, and the data is flowing. And one last thing before we wrap this up. See what I did there? Wrap this up like a VXLAN shell. LOL. Let's return to the client hanging off of leaf 4 and ping google.com to make sure that we can send a packet all the way across the fabric through our handoff and fusion router and out to the internet and back. And she seems to be working. And that, my friend, is how it's done. I hope to see you in a future video. This is Paul Stryer. Have a good day.